quite a challenge after the great lectures that we have already heard in this plenary session. But what I'm going to do is perhaps go on some ground that has already been covered in talks today as well as previous days, but do so in order to make a point which is somewhat different, with a slightly different focus about the problem and nature of consciousness. Now, of course, in the scientific community, especially the computer science community, the phenomenon of consciousness is seen as a consequence of complexity. And therefore, one question that is often asked is, will future machines be conscious? Just a couple of months ago, Europe has launched a €1 billion human brain project. And in the US also, there has been a talk of a comparable effort in looking at brain from a connectivity point of view and try to find an answer to what the brain does and how it might be affected or related to consciousness. And we've already heard in at least two talks this morning about how it has become possible using functional MRI to communicate with an individual, or if an individual has been given a set of different ideas or narratives, and if that person were thinking of them, to just by looking at the points at which the brain has lit up to determine as to what the thoughts were. Now, one of the earlier talks looked at brain activity, the activity in the neurons, and looked at the behavior, large-scale behavior, and looked at characteristics such as the power law and so on. And what's interesting is that something similar is also being done these days using similar graph theoretic models for social networks, for example. I have a PhD student who's looking at large-scale social networks, and we find once again that the behavior has a characteristic power law associated with it. And therefore, if one were to take a step back, one sees that, all right, here is the connectivity of all the hundreds of millions of individuals who are part of a social network or different social networks, some of which are connected. And this behavior has signature or patterns which are very similar to the behavior that we get for the brain. Now, what we are doing is saying that, well, these signatures are associated with different levels of consciousness, but we are not doing so for the social network, which tells us that clearly, while all this activity is a signature or a trace of consciousness, it itself cannot lead us to what the phenomenon of consciousness is, because we are seeing a parallel of these traces in a social network, and we would generally agree that the collectivity of all the individuals on Earth cannot be viewed to be conscious in the same sense as an individual is. Okay, now, where do we go out of this or from this? First of all, we have the question of autonomy. It's been found that the decisions that an individual takes are already prefigured in the brain in that specific, let's say, motor cortex region about 7 seconds earlier. So in other words, the sense of autonomy that we have may be an epiphenomenon, that it's not really that those decisions were taken in advance of the activity starting inside the brain. And we also know that a lot of our ordinary activity or behavior is a set of scripts. And looking at all of this, I suppose what happens is to see another connection. I'm reminded of the conversation that Shwetaketu has with Uddalak Aruni, which is what we saw in the show last night, where what the father tells the son is that while you cannot see this category, if you will, directly, but you can see traces of it. And perhaps what needs to be done, and that's why all the physiological studies and all other studies are so important, is to then, looking at all of these traces, infer what this phenomenon might be like. Because, once again, to go back to the time of the Upanishads, Shwetaketu, we do have in Mundak Upanishad the description that consciousness cannot be an ordinary science. Why? Because any ordinary science must be linguistic. It must deal with relationship between objects, right? That's what science is all about. But consciousness is not an object. Consciousness is what we use to look at objects. So we can have sciences of various different kinds of objects, but we cannot have a science where consciousness can sort of look at itself. Now, of course, what the sages of the Upanishads said was that that you can infer or you can speak of certain broad characteristics, although it's transcendental. In fact, that's the term why the phrase transcendental is used about the mystery of consciousness. But you can infer certain things about it. And perhaps such inference can also be drawn in the many different ways consciousness of ordinary people, of all of us, behaves when people are creative. And there's this famous study by French mathematician Hameroff in the late 19th century, where what he did was he wrote to a lot of creative scientists and asked them as to how exactly they had come by their discovery. And most of them said that they had made their discovery not when they were using logical thought, or the discovery was not a consequence of reasoning, but rather came sort of spontaneously. And so that would imply that that its source, because that moment of creativity is a kind of a break in an ordinary sequence of seeing things. And therefore, this study of how creativity happens could illuminate the nature of consciousness. Certainly the nature of extraordinary consciousness that we are talking about here. Now, you also have savants who have, these are people, for example, who are very severely autistic, and some of them have astonishing mathematical and artistic abilities. Now, we have the well-known book by Oliver Sacks titled The Man Who Mistook His Wife for a Hat, where he speaks of, Oliver Sacks is himself a neurologist. He speaks of how he's looking at these two twins who are severely autistic. They don't have much of a numerical ability, but they are able to recognize prime numbers, including prime numbers which are very large. And this is an experiment, or this is a study which was done by him in the 60s before it became easier to recognize prime numbers using computers. And likewise, one of these boys opens a box of matches, and the matches fall, and the boy says 107. And then Oliver Sacks goes down on his knees and counts the number of matches, and they're exactly 107. So clearly there's no way this boy could have counted them as the matches fell. So what this does is, and what I'm trying to do here is talk of anomalous behavior, because I want to talk about certain possibilities associated with consciousness that we may not have gone over in our discussion over the last couple of days. All right. We already talked about objective and subjective sciences, apara and para. But what I want to talk about now is, could there be ways of knowing other than the rational, which is, of course, what para sciences are supposed to take you to. There's also the connection between cosmology and myth. Many of these Vedic books claim for themselves that they are a narrative on the science of consciousness. They say, for example, mythology, as given in the Puranas, is a way of representing the paradoxes which are associated with reality. And it's through these paradoxes that one is trying to reach, so to speak, to the heart of the mystery of consciousness. In fact, there's a very interesting dialogue in the Bhagavad Puran where Yudhishthir goes to Narad and asks him, what is the way to obtain, or what is the purpose of one's life? And how does one obtain knowledge? And what Narad tells him is that, well, you study all the normal sciences to the extent you can, but then this study will take you to paradoxes of different kind. And once you have reached these paradoxes, that is what will give you the tools that you need to go on to the next level. Which is, in different terms, what one is trying to say is that all of us in our lives have those moments of epiphany. We've reached a point of crisis in different, perhaps in an academic discipline or in one's life or in one's understanding of one thing or the other. And then there's a crisis. And at that crisis, sometimes, there is an epiphany. And then suddenly you reach a new state where all that crisis gets resolved so that you have reached a next level of understanding. And therefore, these paradoxes could be a ladder. Now, as to where this ladder goes, this ladder could not stop. Why? Because if this ladder was finite, then in principle, you should be able to describe the nature of this ladder through some linguistic narrative. But that negates the point that we made in the beginning, that the mystery could not be encapsulated through language. Now, what I'm trying to do then is that if that is the case, then one might ask, should one give up? And what I'm going to make the point in my talk is that, no, it is possible for us to speak in terms which are much more than anecdotal, and perhaps we would be able to establish that this phenomenon is much more than what any mathematical or other structural approach to reality is going to take us to. All right, this is something that has already been covered, and Menas Kafatos spoke very eloquently on this, that the universe itself is one with consciousness. Now, we do have duality at the phenomenal level between matter and consciousness, as we all know. And we also know that there are counterintuitive ways in the workings of the mind, which Menas in his talk yesterday described as mind itself being the problem in approaching the heart of consciousness. First of all, you have to destroy the mind, and only then mind can be an ally in making further progress. Now, of course, there are these two approaches. This is the Western approach, materialism, where cognitive capacities arise out of the body, while this is the inverted tree of the Bhagavad Gita, for example, that all the multiplicity that we see has a single source. There is also, in Indian way of thinking, this magic cube, which are 6 different ways, all of which lead to different paradoxes. So these are the 6 darshanas. As if one were in a cube, the 6 different sides provide you different perspectives, which are different, but then when you examine them, that will tell you how you can join some of these perspectives to obtain a higher level of understanding. This is a different way of representing the same thing. All right, now we've already spoken informally about tension between opposites as a hallmark of consciousness. And this tension between opposites means that paradoxes are embraced. The Greeks talked about the universe being either things or change. And what's very interesting is that quantum theory is one which says that really these two perspectives are the same, because in quantum theory, the equation, the Schrodinger equation, is that the change itself is equal to the state. The rate of change of the state is equal to the state. So these are the two ancient paradoxes or perspectives that the Greeks talked about. All right, now we have two complementary representations. Without observation, system unfolds deterministically. And in quantum theory, mutually exclusive attributes coexist within the system, and observation leads to choice between different possibilities. And, of course, measurement leads to collapse. System has entangled subsystems, and entanglement is stronger than random correlation. So that if you had two entangled objects which are very, very far apart, and if there was an observation which was associated with heads and tails, if you got this from observing this particular object, you'll get just the opposite, observing the other. Now, of course, there are two interpretations. One is the old Copenhagen interpretation with its system-observer divide. And it's not a realistic position, because what it says is that you cannot speak about what the universe is. You can only speak about what you can know about the universe. And the measurements are associated with a probabilistic interpretation. Now, on the other hand, the many worlds interpretation is a top-down view. And the problem, although this many worlds interpretation is very popular with physicists right now, cosmologists, people who do quantum computing, the problem with the many worlds interpretation is that it makes the superposition state as one where the observer is already in a entanglement with the two different possibilities associated with, let's say, the Schrodinger's cat. So in other words, it sort of takes away the freedom that was fundamental to the process of observation that is central to the Copenhagen interpretation. Now, of course, there are similarities, as we have seen. The general perspective on consciousness that philosophers or sages have spoken about, and the very nature of this fundamental duality that we have seen in quantum mechanics. And one way of looking at it is to do what has been done by several people and see consciousness itself to be a quantum process. Although one would then say, or one would ask is, how is it embodied? Because that problem of embodiment would still remain. The biological system itself can be seen as a quantum structure, or one can, and this is an idea that has been discussed here earlier on by several speakers, that consciousness itself is a universal field that is reduced by the brain. All right, now, what has happened in the last 4 or 5 years is that scientists have started looking much more seriously at quantum states in biology. When some time ago, say 20, 30 years ago, quantum theories associated with consciousness were proposed, the critics said, well, the brain is a very noisy system. It's a, the temperature is high, there will be decoherence, and therefore, on physical grounds, we cannot accept the idea that consciousness would have a quantum mechanical basis. But in the last 3 or 4 years, serious theories have been proposed which are generally accepted, at least for the very first of these 3, photosynthesis, that photosynthesis has a quantum mechanical basis. Quantum mechanical ideas have also been proposed for navigation by birds, as well as olfaction, or the sense of smell. In photosynthesis, you have the chlorophyll molecules, which are green, and you have proteins surrounding it. And what happens is that light energy goes to the molecules in the center where the reaction takes place, where the energy finally gets transformed. And this process, normally one would have thought, because to reach the reaction center, there's quite a distance that after photons have impinged on the material, they have to go there. One would have thought that there would be a lot of loss along the way, because it's all random, because the photons would be received at different times. But that's not what happens. There seems to be a kind of a correlated, highly correlated, or a quantum process at work, so that the energy of these photons reaches the reaction center all together. The person who's proposed this theory, Professor Fleming of University of California at Berkeley, they've done theoretical analysis, and it's generally accepted. So this means that, well, contrary to what one would have thought, quantum processes can remain in a coherent state in a biological system for times which are much, much longer than people had previously thought. So these are some of the pictures associated with the photosynthesis process. In the avian quantum compass, it's proposed that entangled particles are created, and one of them is then compared to the magnetic compass of Earth, which is what makes the bird know what is the correct direction to fly. In quantum olfaction, in this particular model, the idea is that it's not just the nature of the molecule which is recognized, but also the vibratory frequency associated with the molecule. And therefore, what it makes it possible is for the organism to be able to distinguish, let's say, the same molecule, one of which has hydrogen replaced by deuterium. Now, the shape of the molecule is identical, but the frequencies associated with these two different molecules would be different. And it's become possible. There are experiments which have shown that indeed these two molecules can be so distinguished. And therefore, although, you know, it's in science, it's not, a certain paradigm is not rejected or left all that easily. There is a contest going on. There are those who don't accept it. But I think this particular model has made much more of a headway than one would have thought a few years ago. All right. Now, I just want to talk very briefly about memory because at the recent American Association of Advancement of Science meeting a couple of months ago, there was a lot of excitement based on a study that's been going on for many years in Japan on the working memory of chimpanzees. And it's been found that chimpanzees have memory which is much more than human beings have. And here's a, how do I point to it? Okay. Yeah, okay. All right, let's just...
Tsuzawa at the Kyoto Primate Research Institute in Japan has devised a memory test for the chimpanzees. His star pupil is a 7-year-old chimpanzee. Show him the numbers 1 to 9, and he'll put them in the right order, pointing to them one by one. Every time he gets it right, he receives a treat, a tiny piece of apple or half a raisin. But now, the researchers make things difficult. As soon as the chimp presses the number 1, the rest of the numbers are hidden. He has to remember where the numbers were and press the white squares in numerical order. The positioning of the numbers is totally random. He gets it right time after time with lightning speed and 100% accuracy.
In 0.65 seconds, he can remember the numerals in which position.
Now it's your turn. Did you get them? No? Try again. This time we'll run the sequence at half speed. Still too difficult? Try at a quarter speed. Back to full speed, and you get an idea of how extraordinary this chimpanzee's memory is. So how do humans?
Okay. Well, in the recent presentation in the US, this is an old video. This same chimpanzee, I think he's about 10 years old, his name is Ayumu, now is able to do it for 19, from 1 through 19. And he can do it without any error whatsoever. And obviously we can't match it, and therefore the question that arises is, how is it done? And is it possible that indeed, so is there quantum basis of memory? And in the more speculative ideas that have been discussed here, can there be entanglements across space and time? And what might that mean? In fact, some of those questions were asked in the session today itself. And this takes me to anomalous events in literature. Now, there are all kinds of claims that which are first-person claims about consciousness, about how a person wanted to do something, or something was prefigured. Person thought something was going to happen, there was a premonition, and so on. But as first-person accounts or as anecdotal accounts, science cannot take that as proof of anything which is beyond what would be considered local, because as far as a materialist approach to reality and consciousness is concerned, things should be local. Now, here is this claim in a book written by Sayanacharya, who was the prime minister in the court of the Vijayanagar Empire, and he lived from 1315 to 1387. And he wrote commentary on all the hymns of the Rig Veda. And in the hymn on the sun, he had this statement. And the statement is, O sun, you who traverse 2,202 yojanas in half a nimesha. So the question is, what might he have meant? What does 2,202 yojanas in half a nimesha mean? And this thing had been forgotten, and in fact, his text was, there are many manuscripts that we have from the 14th century, and the Western Indologist Max Muller published this commentary in his book on the Rig Veda, which was printed in the 1880s to 1890s in several volumes. And nobody paid any attention to it until about 20 years ago. Somebody from Pune said, well, yojana and nimesha are well-known units in Indian astronomy. In fact, in Indian astronomical texts, this is the way these units work. One day is divided into 30 muhurtas. Each muhurta is 48 minutes. Each muhurta is divided into 30 kalas. One kala is 30 kashtas. One kashta is 15 nimesha. This is standard. So one day is so many nimesha, and therefore one nimesha is exactly 16 over 75 seconds. There's really no dispute about it at all. Now, yojana is much more complicated. Why? Because yojana is what was used by astronomers such as Aryabhatta, whose name came up yesterday in the show, and by Bhaskaracharya and Varahamihir, and some of them used it somewhat differently. But the standard measure of yojana in the Arthashastra is 8,000 dhanush, or bow lengths. Now, of course, we don't quite know how large the bow was supposed to be, but Mr. Basham, who wrote this wonderful book called The Wonder That Was India, thinks it was 6 feet. If it's 6 feet, it's 1.83 meters, and that would give you the speed of light exactly equal to 3.02 into 10 to the power 8 meters per second, which is an amazing coincidence. Now, what happened was that when I got to hear of it in the 1990s, I looked at this, so I thought, well, one possibility is that when Max Muller interacted with correspondents in India in the 19th century, maybe somebody was already aware of what the speed of light was, and they interpolated that into the text of Sayanacharya, so that Indians could later on claim that they knew what the speed of light was. But this is not possible because there are many original manuscripts which are extant in different libraries. So that's not possible. Now, what I did was, so clearly what one could say is that, well, it's a coincidence, but is there some other possibility that may be associated with it? So what I did was I looked at the descriptions on astronomy in the Puranas, And I found that, in fact, and these Puranas go back to at least 500 AD. The earliest Purana is supposed to be Vayu Purana. And people think that it's certainly 500 AD, if not earlier. And we find that this number, 2202, is present in a certain form there itself. And in fact, in the Puranas, in Vayu Purana, for example, we have a very confused idea related to the solar system, but it's stated that the sun is 15.7 into 10 to the power 6 yojanas from the earth. Now, this is stated very clearly. The rest of the description is totally confused. Now of course, first thing is that this number is much larger than other ideas of the size of the solar system which was extant in ancient world. In fact, generally it was believed that the sun was about 500 Earth radii away from the Earth. This is the general belief. Now, in Kashmir, 1 yojana is 9.6 kilometers, and this also turns out to be the modern figure. Now, the point I'm trying to make here is, I'm not trying to suggest that there were instruments that people knew what the distances to the sun was or what the speed of light was. But rather, I want to take you back to the suggestion that research makes, which is that discovery is made sort of spontaneously. Discovery is not made by way of inductive thought. And if that is true, then it's possible that apart from ideas, and ideas are general shapes, geometrical ideas and other ideas, or forms, which it's easier to see how they can spontaneously arise because the mind thinks in terms of ideas, in terms of abstract ideas or geometrical ideas. But possibly there could be another element to it, and that element is a numerical element. In fact, let's go back to the Greeks themselves. The size of Earth that the Greeks assumed was very accurate. And what is the story that we read in Greek histories about how this size was arrived at? The story is that a gnomon was placed in Alexandria, and the angle that its shadow subtended at noon, compared to when it was exactly overhead at Cairo. And there's a distance of 200 miles between Cairo and Alexandria. So that angle led to the size, the spherical size of the Earth. But clearly it's just a story. Why? Because there was no way that angle could have been measured to the accuracy that is required to arrive at the correct size. So in other words, there are accounts from all over the world where people seem to have arrived at the correct answer in a manner which cannot be rationally explained. And that might be an instance of the working of the mind in a fashion which cannot be explained in any local theory. So is it possible then, as I mentioned before, that correlations could arise across space and time, which of course, as we've heard from different interpretations of quantum theory, that indeed you can look at the double slit experiment and from there conclude that you do not only have entanglement across space, but you also have in the delayed choice experiment, for example, of Wheeler, an entanglement across time. That what we do now seems to be correlated what happened in the past. If we make a measurement now on a photon which was emitted billions of years ago from another galaxy, then depending upon how you measure it, the photon which was emitted would have decided whether to come as a particle or to come as a wave. So in other words, it's possible that the universe is even stranger than what we think, because normally when we look at quantum models of consciousness, we are only trying to look at it from the perspective of it being a theory of wholes, and therefore consciousness as a unity, because when you're looking at a quantum system, you cannot break it down into either this or that, into one aspect or the other aspect. You must look at both those aspects together. And therefore, this suggests that if we can now, the question is, if we can now set up experiments where we could try to, and I don't know how easy that might be, we could try to look at these entanglements or these correlations across space and time, certainly across space. Now, of course, one example of entanglement across time is through literature, which is what I've done, talking about these two specific numbers that we have, which are accepted by everybody, that indeed this is so. And I myself, when I wrote a paper on this in the late 1990s, I said, well, we must look at it as the most astonishing coincidence in the history of science, because as scientists, we cannot view it as anything but a coincidence. Now, of course, there are some people who say, well, maybe there was a more intelligent race on Earth, and now they're all dead, and there was some earlier knowledge which existed and which some people have remembered. I don't accept that. I don't think we have any proof of that. So the only way we can look at it is, and taking a lesson from that, is to see if we can now look at behavior of macroscopic quantum systems which cannot be explained in terms where we are not just talking of wholes, but we are in fact talking about counterintuitive behavior associated with entanglements. Thank you.